Hello, and welcome to our module on concrete strength in the context of construction analysis. The learning objectives for this section are to, first, be able to understand that concrete will have variable compressive strength in its early placement. Second, understand the relevance of concrete maturity. And third, apply a concrete early strength model to aid in the construction analysis process. So concrete is typically assumed to reach a large portion of its full strength after 28 days. However, you can do the math. In almost all suspended bridge projects, structural concrete elements like the anchor beam and tower columns will be under loading in 5 to 7 days. So in order to capture this early strength condition, we can adjust the compressive strength of concrete and mortar. The EIA Bridge Binder Volume 2 for design presents the following values for concrete and mortar strength. Concrete, or F'(C), has a 10 megapascal hand mixed or 15 megapascal drum mixed strength, and mortar has a 1.5, or F'(M) has a 1.5 megapascal compressive strength. Now you see I've written this in the timeline under day 7. So compressive strength testing of concrete and mortar cubes in the field confirms that these values should already account for the reductions due to their early loading conditions, or their 7-day strength. So what does that mean? These values are for 7-day strengths, the values given in the manual, that is, or the binder, rather. So if the loading occurs after 7 days, the material properties are adequate, because all of the component analyses checks are done using these values of 10 megapascals and 1.5 megapascals. However, if we need to find a 3 or 5 day strength, we need to model the concrete maturity. The standard procedure for measuring in-place concrete strength gain for continuing construction activities is ASTM C1074. However, this method requires precise temperature data and establishing a strength maturity relationship with lab testing in parallel to the construction activities. So in lieu of ASTM C1074, I use a different study that is attached below that uses a numerically predicted strength as a function of the full strength of the concrete. So as a function of 28-day strength, we can use an empirical equation to calculate the compressive strength after a certain amount of time t in days. This model uses a regression model in the form of a times the natural log of t plus b that is empirically tuned to normal weight Portland cement concrete with no additives. T is the time in days, and A is defined by this equation here, 1.4035 natural log of B plus 2.9956. And this comes with an R squared, or a value, representing how good of the goodness of fit, an R squared value of 0.98. B is represented by the equation 0.005 F'(C) raised to the 2.2 with an R squared value of 0.91. So this goodness of fit is pretty good. It's good enough for our calculations and to be able to model the compressive strength of concrete of our concrete at time t. And this is based on the full strength that can be achieved, which is that F'(C) value. And in our case, our F'(C) value is going to be that 10 megapascals or that 1.5 megapascals that we can then use to go back and calculate our concrete strength at less than 7 days.